landlocked countries, they didn't realize that the world was not flat until the 1700s. And if you guys ever seen this grid before on a map before, this is called a Mercadian grid. And you've probably seen this map in your school classroom on the back all the time. And this is what you see the world as a child growing up. So the world is actually round. We all know that. And it's actually as early as 500 BC, Pythagoras. You guys all know Pythagorean theorem. He was the first to say the world is round. And this is what you typically imagine the world is today, with latitude and longitude. And everyone's seen this concept before, and this is what you see on Google Map and Google Earth. And the first person to ever create a globe like this is called Martin Behan, and he created this beautiful globe in the 1400s. So as you see, through time, we have progressed our way of seeing the world and seeing space. And today I want to talk a little bit about newer ways to look at the world and space. Alternative systems. And this is a mouthful of words. It's called icosahedral projection, right? And if you guys all know about Plato, he came up with something called Platonic solids, right? Its basic is a cube or octahedron, and then you go up to a bigger space, which is icosahedral. And this is an icosahedron. If you guys ever play magic cards or any other games like that before, you know the 20-sided die. Okay? A 20-sided die is a cyclohedron, and it has 20 sides. Each side is equal size to each other as an equilateral triangle, and they're all exactly the same shape and area. That's why it's a fair die of 20 sides. And how do you turn this into a mapping system? That's the question. You can take each one of these equilateral triangles and divide them into 4 equilateral triangles, and we call that tessellation. So this is one depth of tessellation. The equilateral triangle that you've seen before has been divided into 4 equal-sized equilateral triangles. So this is one level of tessellation. I want to show you guys a little bit more about the mathematics behind this. So you increase the tessellation of this. Now you have a more complex system, and you can start seeing it's a grid for a world that you can pinpoint positions. And this is a tessellation at level 4. And you guys have all seen this before. It's called Battleship Earth. It's in Disney World. It's called Epcot Center. So it's very exciting. Whoa. The whole entire world is covered in this complete grid. This is 10 level of tessellation. So what this really is a system of gridding out the world into equal-sized triangles. And why is this important? It's what I'm going to talk about next. And I have a question. Do any of you guys know what the latitude and longitude of WeWork Boston in South Station is? No? No? Latitude and longitude is the system that you guys all use all the time. I'm curious why you guys don't know it. So the location is at 42.34 blah 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 and negative 71 point blah blah blah. Does this mean anything to you? No? Okay. As I thought. And this is from more a technical standpoint. Each of these are float point numbers, and they're worth 32 bits of your computer space. You guys all know gigabytes and megabytes. 32-bit might not seem like a lot, but in terms of computing size, 32-bit is actually a lot of data. And the accuracy of these two 32-bit flow for latitude and longitude is about 0.11 meter to 11 millimeter. It's a very variable range because when you're doing a float point number, it can be 6 digits or 7 digits. And what is the icosahedral hash of WeWork South Station? And this is the hash that I generated. It looks extremely ugly, But my point of this is to say, you don't really know latitude and longitude, which is 2 numbers. Why don't we have an ugly number? And the binary size this is 66 bits uncompressed. It's only slightly bigger than the latitude and longitude, which is 2 data points. And after compression, it'll be around 22 bits to 10 bits. So you just really understand it's 4 times to 5 times smaller than the latitude and longitude stored in your database. And the accuracy of that is 7.5 millimeters. That's the variation between 2 points. And the cool thing about this system is all those 0s, 1s, 2s, and 3s, there's only 4 different variations. And what we call this is called a quadtree in computer system. So this is a beautiful picture of quadtree. It's an indexing system. So imagine you try to divide the space into 4 squares, and you try to pick out the perfect position of those. And by doing this indexing system, you can quickly find a location from one place to another place. And the most ultimate part of this quadtree is, you see the numbers going from 1 to the other one, whatever it is. It's actually following a parent-child relationship all the way down. So by knowing a point, you know what the parent point is. If we go back to the previous picture of that whole entire grid world, when you know the location of a particular triangle, you know the parent triangle. And this is very powerful for aggregation of data in locational services. And we have previous talks about different people with Google Maps. They have way too many data points. And you search for local restaurants on Yelp, you have 200 points showing up on your map. That's way too many points. And how do we think this out? How do we aggregate this data? And what if we have a political election and you try to see who's voting where and in different locations? How do we aggregate that data to produce more visually pleasing results? So what do you guys want to do with this system? It could be any type of businesses using locational data. It could be sales, it could be international trades, it could be weather forecasts, and different types of systems. All these different systems could use this type of new and improved locational service. And by increasing, but how do we get the resources and funding to get improved research on these type of resources? Open source databases and APIs for you to use this location data. And this is what I'm going to show you. Petridi.sh. So this is Petridi.sh. I'm creating a WebGL system that can go straight to your computer's browser, Chrome, Firefox, Safari, whatever it is. Your iPad, as long as it's iOS 8, will run WebGL. Your Android system, KitKat, all will deploy at the same time, without having to make an iOS app, an Android app, and a website. I'm going to connect to the system real quick. That was my two-factor authentication system. I'll explain what that is. So Petridi.sh is trying to take the concept of, we have science in this world that we need to improve and teach. And how do we help the new generation of people to learn about these sciences? And I'm starting at, the first thing is the atom. And if you have ever seen an atom, it's imagined as a sphere. I'm going to take a commonly known atom, so you don't get too confused. Everyone knows what iron is, right? The iron has 26 electrons, 26 protons. And we have this beautiful sphere of iron atom. And this works exactly the same on your iPad or your Android. You can pan and scroll in the system, and this is exactly the same grid that I've showed you guys before. You can zoom, and on your iPad, you actually have the gestures to rotate. These are basic features that I'm developing for the future of mapping system through a game. And this game right here is very simple. You guys all have played Minesweeper before, right? It's the oldest game on your Windows computer as a kid. You have no idea what's going on. You double click constantly, and you die. And this game is exactly the same game as Minesweeper. But the cool part about it is you have an iron right here that has 26 electrons. And those 26 electrons are the mines that you don't want to hit. So, oh man, I hit an electron on the first hit. Alright, so you hit a tile with the circle system. It shows you how many electrons it's next to, just like Minesweeper with 1, 2, and 3s. Let me just play through this and just give you guys an idea of how this works. Here we go. I had a really lucky opening. I have a bunch of tiles open. So now you can see there's these spaces that I can mark them as electrons, just like Minesweeper, and progress through the game. So it's a very simple game using exactly that geolocation system, which is kind of my unit test for my API that I'm developing. At the same time, being able to teach children about atoms. And that's pretty much it. And if you want, you can always play this game for free, completely free. I don't want money from consumers. I want money from the government. So it's Petridi.sh with a dot before the SH. You guys have any questions?
Yeah, so what are the ramifications for navigation? I mean, obviously, like, we navigate using Latin long because that's what we've done since 1492, right?
Yes.
So, I mean, I'm thinking, like, in terms of, like, a whole generation of having to relearn, like, the shorthand. So, like, if I'm navigating based on a GPS, I can hit a button and I can read off to the Coast Guard or any other authority, what, degrees, minutes, seconds, right?
Yeah.
And most of us know that shorthand. Now, I'm looking, you've got a unique identifier for each little triangular grid space, right?
Absolutely.
So I might know where I am. Now, it looks like, you move up levels, like, so if I know the child, I know the parent.
Yeah.
So theoretically, if I know that parent, I know the next level parent. So I can report my general locale to whoever I need to. But how do you shorthand that? I mean, even if you compress it down and your hash is 12 characters, I mean, how am I gonna, I can, by looking at a map with Latin long, I can very quickly be like, yeah, I'm within 3 or 4 miles of this area. Come look for the wreckage, I'll be floating in the middle of it, right?
Yeah,
it's gonna be a little bit harder maybe, like if I've got to come up with a 12-digit hash.
Yeah.
Like, so thinking about that, like, how do you see us progressing to a new system of navigation using, I mean, because like the precise location is brilliant, I mean, I love it, I get it. But how do we make that transition? Do you have any thoughts on that?
The exciting part about this is it's not made to be a system to completely replace Latin long.
Okay.
And I've developed an API for you to convert back and forth very easily. And for calculating distance, using Latin long is still better, using sines and cosines.
Okay.
But for calculating areas, this is a much better system. Because instead of specifying a point, you're specifying an area, which is describing more data.
Okay.
So in the future, instead of drawing GeoJSON of a river or a lake, you can create 4 index of a tile.
Yeah, sure.
Then you have a really interesting shape already with just 4 data points.
So to follow that up, if you don't mind. So like think about like micro-targeting in an election, right? So like typically the way we micro-target now is like, within a mile of this location or this census tract, this census block, so you would mention like, okay, so people vote in this polling place, I know their polling place and I know their political jurisdiction, their precinct or ward, whatever. How do we go from that down to like, because the gold dust is going to be within these 4 triangles, I know that I've got 6 out of 10 good Dem voters, right? And I know their ages because, we mapped it all out. Again, how do we go from like, okay, I know they're at this polling location, I've got a rough idea they're in this area too. I know that this guy lives in this little triangle and he's a good Dem voter, and I've got these demographics on it. Does that make sense? You see what I'm saying? Like,
absolutely.
Okay.
It's all based on the API. API lets you get your current GPS location, latitude and longitude.
Okay.
convert it to the hashing system.
Okay.
It's really, let me bring it back to the slide. It's really a good way for you to really four big ways that we're really excited about our investments are really so the first way is that
your idea, I think, is one of the cooler technology ideas that I've seen come out of Boston and the co-working space that we work at recently. So, real quick, just give us like a 30-second elevator pitch.
okay, so I'm basically creating a geolocation system that's gonna bring a cohort of awesome games for children. The first thing is we're exploring the spaces of the sphere of the atom, the electron clouds and electrons. And then we're going to move into an actual real spherical world where children can grow their cells and compete against each other.
And this is based on a totally new way of graphing polar coordinates?
It's not completely new because everything in science has been built on the foundation of others. I can name off a whole list of sources and citations that I can, base my work on. But I would just say this is a new way to approach it and a new way to apply it.
And your first use case is for children. Can you talk a little bit more about that? What brought you to that point?
What brought me to that point is I've always wanted to find out a good way to find a go-to-market strategy for my product. And I've realized making a game has always been my passion. And making a game does not have any limitation of what you're supposed to do. There's no goal, there's no end results that needs to be reached other than having fun. And your technology has to work. So that's why I decided to make a game. And if you gotta make a game, you gotta make it educational. And because I don't want to get a freemium model on my product and charge people money, I'd rather have children play it and have the government pay for the science funding.
That is awesome.
Yeah.
So Victor, you are a real startup entrepreneur, bootstrapping your own small business right now. Can you just talk about what that process is like for you emotionally, what you found really helps you to work and be productive? Talk a little bit about your personal experience when you started founding.
Absolutely. One of the biggest things for me is I'm trying to spend as little money as possible. So far I've only spent $40 on this business. But the important thing is I am a developer and I love all the free resources out there. Without Stack Overflow, I wouldn't be here today. Be able to code this whole entire system together. And without all the community around me, WeWork is a great community and it brought people with skill, talents, marketing, and ideas together. So, yeah.
Victor, you're a real technical genius, and I know this firsthand. What would be one piece of advice that you would give to someone who's trying to learn how to code, say, in the first year?
One of the most important thing about programming, I think, is understanding how the machine works. If you're a mechanical engineer, you try to understand how a joint work, a socket, ball joint work, and it's very important to know that aspect about a computer. Instead of buying all the pre-assembled pieces and putting it together, knowing the nuts and bolts is very important. So, as I talked about my technology, there's all these words like bits, there's all these words like bytes, there's indexes and hashes. It's very important for new programs to learn those things before they jump too far ahead.
Okay. Just a couple more things. One question that I really wanted to ask you. Okay. So, give me one piece of advice that you would give to a startup founder. No, okay, I'm sorry. So let's say I'm an MBA type, okay, and I have no technical ability whatsoever, but I have a brilliant business idea. What would you say would be your first or next steps in trying to take that from idea to prototype?
Oh, absolutely. Creating a business plan is something that you pitch in the MBA school. And creating that business plan in the computer world is very important too, as well. And usually people call this the project roadmap. And the project roadmap is a business plan. And that is very important for an entrepreneur to have.
Okay, yeah, that's great. And finally, where can we find you and where can we find Petridi.sh online?
You can find Petridi.sh online. Just put a dot before the SH. You're good to go.
Okay, and you? Where can we find you online?
Oh, you can find me online by searching for Victor Zeng. I'm usually the top Google search.
Awesome. Thank you, Victor. You want to give me your mic?
Yeah.
Cool. Perfect. You guys have any questions?
It looks good.
Looks good?
You look-
Sasha, you look good, babe.
Oh, thank you.
You look good.
Yeah.
We got behind the scenes